The big question of whether there is life beyond Earth is accompanied by an ironic asterisk. There is no universally accepted definition of life itself. However, we may not require one. We only need to detect signs of life in an exoplanet's atmosphere to gain a better understanding of what those look like on Earth. Elon Musk, the CEO of Tesla and SpaceX, has developed a pretty strong interest in the idea of putting humans on another planet, and he's been working hard to realize this dream. Aside from Mars, he's also looked into other planets, with a subsequent focus on Venus, from which several probes were sent to examine the planet with collaboration from the Soviet Union, and Elon Musk has just leaked what one of those probes discovered on Venus. Join us as we look at what was discovered on Venus and what this would mean for humanity. Many people consider Mars to be Earth's sibling, despite the fact that it is 34 million miles away. However, Venus is 25 million miles closer to Earth at its closest point in orbit. Earth and Venus are also roughly the same size and mass, whereas Mars is roughly half the size of Earth. Both planets appear to have been twin sisters at some point in their histories. According to a 2016 paper by NASA scientist Michael Way and his team, Venus may have had water until 700 million years ago. If this is the case, could Venus's current state be indicative of Earth's future? That's not to say that Earth and Venus do not have differences. Knowledge was gained largely as a result of the Soviet Union's study of Venus. Trends in space exploration have shifted away from Venus's hot and thick atmosphere and toward Mars's colder and thinner atmosphere. There hasn't been a lander sent to the surface of Venus since the Soviet Union launched Vega 2 in 1985. Gregory Shelnut, a distinguished professor of geochemistry at National Taiwan Normal University, said that Venus is indeed Earth's sister across the board. The Soviet Union advanced in the space race by exploring Venus between 1961 and 1983, launching 28 spacecraft as part of its Venera program. Not only was Venera 8 the second man-made object to land on Venus, but it was also the first fully successful landing on another planet. Venera 7, launched 2 years before, was the first partially successful landing on another planet. However, a parachute failure caused the lander to freefall, causing Venera 7 to roll over after first touching down, severely damaging the lander and also preventing it from sharing continuous high-quality data. One of the shocking discoveries made by Elon Musk is a Soviet lander that was sent to explore Venus, and according to Musk, it has been kept a secret until now. This Soviet lander was sent to explore the surface of Venus in 1983, but due to a communication error, it was never heard from again. Now, decades later, Elon Musk has revealed that he uncovered the lander and its terrifying contents. The lander was able to send back pictures and data from the surface of Venus, and when Musk analyzed the data, he found something horrifying. The data revealed that the planet's atmosphere is filled with a toxic gas that is poisonous to human life. Scientists are still trying to figure out who or what could have built the structure and what its purpose is. This is a truly shocking discovery and could change the way we view the planet Venus. We may never know the full extent of what lies beneath the surface of this mysterious planet. During the Soviet Union's Venera program's 18-year run, 13 spaceships successfully entered Venus's atmosphere, with 8 landing on the planet. Since Venera 8 was the most successful in Venus's exploration, let's focus on it. Well, Venera 8 was launched on March 27, 1972, with the intention of measuring Venus's atmosphere and surface. The journey to the planet took 118 days. The section of Venera 8 designed to descend through the atmosphere to the surface was outfitted with a refrigeration system to keep the equipment running as long as possible. This is because surface temperatures on Venus can exceed the melting point of lead during the day, which is about 620 degrees Fahrenheit. It was equipped with a gamma-ray spectrometer, a gas analyzer, an altimeter, a photometer for measuring light, pressure and temperature sensors, and a radio transmitter. Venera 8 was designed to validate Venera 7's measurements of Venus's atmosphere, which, despite landing complications, managed to record that the atmosphere was 97% carbon dioxide. It also measured a surface temperature of 887 degrees Fahrenheit and a pressure of 9.0 MPa compared to 0.1 MPa on Earth. These measurements confirm that there is no water on Venus's surface and that it is not a habitable environment for humans. Venus, too, lacks a magnetic field, or if it does, it's very weak. This is due to the surface of Venus approaching the Curie temperature, according to Shelnut. For those not familiar, the Curie temperature is the temperature at which a material loses its magnetic properties. The measurements taken by Venera 7 were confirmed by Venera 8, but due to its relatively successful landing, Venera 8's photometer revealed something unexpected. Despite the fact that it was quite impossible to see through the hazy Venusian atmosphere to the planet's surface, Visibility on the planet's surface was comparable to that of Earth on a cloudy day, with visibility of about 1 kilometer in each direction. Clouds were spotted in the sky at a high altitude. Engineers working on the Venera project realized that it would be possible to take photographs on the surface after Venera 8 landed. So, in 1975, Venera 9 not only landed successfully, but it also became the first lander to photograph the surface of a planet other than Earth. Venera 8 survived for less than an hour on Venus's burning surface. Venera 8 measured the concentrations of 3 radioactive elements in Venus's surface material during the 50 minutes and 11 seconds that it transmitted data after landing: thorium, potassium, and uranium. These are trace elements, which means they're found in small amounts and in basalts, such as those found in Hawaii or at mid-ocean ridges. Shellnut, who's always been fascinated by Venus since he was 10, has followed Venus's research as his career progressed. He recalls using crystallization modeling software to study rocks on Earth when he came across the gamma-ray spectrometer trace element data from Venera 8 and being reminded of all the Venus probes and their geochemical data. Venera 8 was unusual in that it displayed a significant anomaly when compared to the data from many of the other landers. According to Shellnut, even with 30% error margins, the trace element values obtained by Venera 8 were just too high to qualify as basalts located near a mid-ocean ridge or in Hawaii. The other Venus landers, unlike Venera 8, recorded geochemical qualities more akin to those found in or near a mid-ocean ridge. The majority of the natural radiation we receive comes from potassium and crystal rocks, which would also be accurate for the Moon, Mars, and for any terrestrial planet. Using Earth-based crystallization modeling techniques on the trace element values of the Venera 8 landing site, it was determined that those values may be similar to a type of continental crust on Earth known as Archean greenstone belts in a paper published in 2019. The Archean period on Earth lasted 2.5 to 4 billion years. Greenstone belts are some type of continental crust that a lot of scientists believe chemically evolved from mafic basalts over billions of years. During the Archean, the Earth looked very different. The planet had only recently formed and was extremely hot. Because of Earth's heat, its tectonic regime during this time, as well as Venus's current and past tectonic regimes, remain a mystery. There's currently no evidence of plate tectonics on Venus as we know them on Earth. Venus's topography differs greatly from that of Earth. There are quite impressive volcanic edifices and landmasses the size of Africa, with one key difference. Well, when we look at the Archean Earth, there is a lot of debate about whether modern plate tectonics were active during the Archean. So how did these landforms on Venus come to be? How does all of this deformation happen? On Venus, there's evidence of compression mountains. There are rifts, so it's obviously tectonically active, but it's not broken up into plates. Venus, then, is most likely operating under an Archean tectonic system, not a modern Earth plate tectonic system. Something quite similar to old Earth during the Archean era, where there may not have been defined plates, and the temperatures of the interior of the Earth was much higher. Venus has long been thought to be geologically dead for millions of years, but the discovery of active volcanoes on the planet has raised new questions about the planet's surprising geology.